Good afternoon. So we are here for the last session of the conference, the panel discussion. In the morning, we had some 4 excellent lectures. One by Utkarsh on challenges in regulation, one by Mr. Vivek Piplani for graded approach, then Solanki gave regulatory documents, and Somen Sinha gave the legal and regulatory framework. So I was talking about the 4 lectures in the morning, which were very relevant to the topic of this panel discussion. In fact, all the answers that we were looking for within ourselves, most of them were covered in the morning talk. Maybe to add, and I think that was a good point of this particular thing. So it appears that AERB has, already had looked at the nuclear renaissance and all that is likely to come through. But notwithstanding that, now let us look at the title of this panel discussion, and that is Innovations in Regulatory Approaches for Next Generation NPPs and New Entities in the Nuclear Landscape. Now this is a very long title, and then I tried to sort of split it and try to see what meanings we can sort of derive from that. So regulatory approaches, if you look at Google or dictionary meanings, it appears to be one meaning is, okay, whether they are rule-based regulations or the performance or goal-based regulations, and that is one. Well, it could be that the regulation and their application for a particular case, and I think it is the second meaning that that is more appropriate here, that how can you sort of make innovations in the regulations and the application of those regulations to a particular safety case. Now, this is to be applied to next generation NPPs. Now, here again, I cannot make out what is next generation NPPs when we are already sort of operating the most advanced PHWR and also the KK units, which already seem to have, I don't think any more advanced design has been proposed so far. And if we can regulate that with our existing regulations, then I don't see any sort of difficulty if any other design comes up for that. There is also new entities on the nuclear horizon, and I don't see any in India. That is, people are talking about SMR, but there is no practical proposal in front of AERB. But however, we will give some give some discussion to this. So with this kind of explanation, that is, let us talk about applicability or the regulations, their application, and to be applied to the new entities on nuclear horizon, if you can think of anything. I will now go, to my panel members, requesting them to make a presentation or take about 5 minutes and express their views on this topic. So first, would you like to?
Raghavan.
Mr. Raghavan, he is Vice President and Head of Power Business from Tata Consulting Engineers. And we are happy to have somebody on panel who is non-DAE, I'll put it.
Thank you, Mr. Chande. Good evening to all. I'm Raghavan. I'm heading Power and Nuclear Business in Tata Consulting Engineers Limited. So this is a very important and interesting topic, though some of the presentations of today covered many aspects of this topic, I would bring in from the industry perspective and also from an engineering perspective, what are the things we need to do if we want to accelerate the capacity addition of nuclear power in India. So currently we have about 8 gigawatt of installed capacity in India and about 5 to 6 gigawatt of nuclear projects are under implementation. So about 13, 14 gigawatt is either operating or under installation. You might have seen the DAE's aim. We should reach to 100 gigawatt of installed capacity by 2047. That means we have to accelerate at a pace about 10 times the current capacity within next 25 years. That is a very huge task. Suppose if you want to achieve, this is really important because of the energy transition that is being talked and being implemented globally, and also we have done tremendous work in the area of solar in the last 10 years. But solar and wind alone cannot provide the green, clean energy on a sustained basis because these are all intermittent sources of power generation. If we want to decarbonize our industries, we need continuous base load of clean, green power. So the only alternative we have in the clean form is nuclear, which can provide continuous base load in place of fossil fuel. So when we think of such a rapid capacity addition, we need to adopt new technologies. It could be imported reactors. Right now we are having LWRs imported from Russia. It could be many other imported reactors. And also we need to have several entities. The entities could be other PSUs, which the current regulation allows, or it can be some business agreement between NPCIL, other DAE entities with private companies. So as of now, it is not defined. Suppose we need more entities into the nuclear sector, and also we need new technologies. So that is the topic. If such being the case, what are the things we need to do for accelerating that innovation? This is very important because innovation in regulatory review process is also important to cope up with the change, because so many reactors, so many plants to be executed simultaneously. So the key challenges, I would say, this is balancing safety and speed in the review process, because we need to, there is no compromise, there should not be any compromise on safety, but at the same time we have to bring in speed in the regulatory process. Second one is addressing the public concern or perception in nuclear energy. That also the role, the regulator has an important role to play. Third one, when the new technologies are coming, SMR or sodium-based, lead-based reactors are coming, regulators are also should have necessary technical know-how. These are all the challenges. So with this challenge, I would say there are few points already been covered. Few more I would like to highlight as a part of the panel discussion. One is we should adopt a risk-informed decision making, because the regulators are already started looking at the probabilistic risk assessment, which will focus the key risk factors so that they can derive the insights to make the regulation very focused and target-oriented. So that is very important, risk-informed decision. Second one is the performance-based regulation. Here, we can regulator can set the defined performance objective, like safety margin, without going into the technical solution aspect, and leave the technical solutions to the designers, reactor designers, so that we can bring in innovation in the design. So graded approach has been discussed exclusively on one of the topic in today's presentation. That is also very important to bring speed in the regulatory process. And another aspect, we need to have a streamlined licensed process. Here, what I mean by streamlined, we can standardize the licensing approach for standard reactors. Suppose in future, if we are going to have SMR itself is a modular, standardized, factory-built reactors. So we can have a standardized regulatory approach for such SMR reactor, which is common, it can be implemented, it can be installed anywhere. And also regulators and project developers should engage very early stage pre-licensing engagement so that many of the safety-related aspects can be discussed and resolved before a formal application. So early engagement between the regulator and the project developer could be one important aspect. Third one, I would say as a part of the streamlined regulator, we understand NRC has introduced a single license for construction and operation. Instead of going for a separate license for construction and operation phase, there is a combined one-step license. So similarly, we can look for, if applicable, we can adopt, because NRC is already going into one-step licensing process. Another important aspect is how we can bring in digital transformation. That is important. Now we have advanced software, artificial intelligence. So how we can use the digital twins or advanced analysis techniques so that the review process can be, the time can be optimized. So that is very important. And also we can go for, instead of paper-based application and all, we can go for complete digital documentation, right from application, various reviews, public comments, so we can go for digital documentation. Artificial intelligence, in case of operating reactor, we can collect a lot of operating information using artificial intelligence, make data analytics, which will facilitate the regulators to make faster decisions. So that is also important. And global harmonization and collaboration also was discussed, very important. We need to collaborate with other regulators so that we can standardize some of the regulatory review processes in line with other regulators. Collaborative licensing. This also happened between US and Canada because they have a collaborative agreement for SMR licensing. One country approves, other country will adopt without much of the review process. So with advanced technologies, public participation and transparency, definitely we can speed up every stage of the review process. And finally, I would say capacity building and knowledge management is also a very important aspect across all the stakeholders. It is not only the regulator, because it's all the stakeholders, developer, manufacturers, engineering companies, all the stakeholders, there should be a capacity building and knowledge management which would bring in speed. And when we have advanced technologies like fast reactors, molten salt reactor, and in future we will have fusion reactor. So probably we can think of making a dedicated safety assessment and specific process for these reactors, future technologies. It may not be immediate requirement, but regulators should start thinking of having a specific safety assessment for those reactors. International collaboration is also key to speed up the regulation process. So why I'm saying is, I will give an example from an engineering perspective. We completely converted the 2D based engineering to 3D engineering for our fleet mode implementation of 700 megawatt. Because of the standardized design approach, we could optimize the design. I can quote the specific example, but what I'm saying is because of the standardization and integrated 3D engineering, we have optimized the engineering time. So similarly, use of digital tool will bring in lot of saving in the review process. So this is across the value chain, manufacturing, inspection, everything digital tool, digital twins and automation can bring in a lot of focus in the entire review cycle. So to conclude, I would say as a forward-looking thing, we should embrace innovation, which is vital for accelerating the nuclear plant implementation in the country. Thank you.
Thank you for covering the entire gamut in this process. May I now request Mr. Koley?
Very good afternoon. Actually, during lunchtime, I talked to Mr. V.K. Gupta was telling me that how ARV is transforming itself to gear up these things and what are the changes, whether it is good or bad. So I thought I will talk about that, how ARV is transforming itself to take up these two challenges. If you see that Indian regulatory system per se, it has been developed with the technology development itself, along with that. And I think so far it is 40 years and then performance of our regulation is not bad. In fact, it is much better than many of the advanced countries. And I can remember that when in early 90s I joined, we are sitting some 10 to 15% in Central Complex and looking after 3 nuclear power plants, RAPS, MAPS and NAPS, and certain fuel cycle facilities. Everything we used to do together. And today I'm heading that same division, OPSD, where not much, around 30 people today as a reviewer. But you see, we are looking after or supervising around, say, 22 reactors. The 22 power plants means 40 of reactors, and so many fuel cycle facilities, and also that norm industries, they have been added. So how this is done? You see that today in AERB, it's not like earlier one. Today we have a support of a separate directorate which is looking after inspection planning, a separate division with a institution which looks after safety analysis, R&D. We have a separate division for health physics. So all this support, it matters to take the decisions and going forward. Also, you see this, along with this, AERB also have a regulatory process integration through its integrated management system. And that, along with that, AERB people are now responsible for taking decisions. That also counts. So how slowly we are changing. So if you see that with respect to this next generation technology, that is new technology, we handled KK, which is a VBR, which is a generation 3 reactors. It came first time when in India. We successfully reviewed it, and today I can tell that there is a LWR code which is much better than any of the code in this domain worldwide. So this job has been done. Even in post-Fukushima arena, if you see how AERB acted, post-Fukushima, the first thing that changes in the dose criteria, it was done much faster than any other country, including even IEA. And we have introduced a level of defense in depth. You can hit a level or sub-level, whatever. But it was also done much ahead of any of the country in the world. So this, all this support, all this, how it can be done? It is, apart from your BRC and IGCAR R&D support, our own R&D, our own research team, that helped us in doing this thing. And in the last decade, if you see the new entities, I can see that Bhavini, one we introduced, and now Asini. The both of them has come along with, I can tell, NPCL or IGCAR, which are veterans in this domain. So it's a hand-holding process that gives us the confidence to take how it is. So whenever a new entity comes, that has to come in this, like this manner. So it will be having a satisfying regulatory. And also the early introduction, the PFBR, if you see, PFBR research, we introduced in very early stage. So our research team, our people have done much of a research work on this area itself. So our regulation also, if you see, in the early days itself, we have done a, not a code, design code, but a design criteria document which guided this review. So definitely I can tell our current structure itself, we are continually changing to adopt the things, and we are capable to do it. Thank you.
Mr. Chafle.
Good evening to all. See, just picking up actually from this theme of this conference, So we talked about that nuclear renaissance. Now why? We know that certain things are actually imminent and we have to go for a cleaner energy option. And nuclear is capable of filling in this gap. So that is beyond a doubt. So nobody doubts that. Now why then so much of talk is there? People normally associate this nuclear power with like that when the power plants are being set up, that it is a time and cost overrun. It takes a lot of time to set up. So that's why people associate it with the cost. But one thing is lost in this process is, though it takes time to set up, it is a cost intensive also, but then its life, unlike many other plants or this thing, it runs 40 years, 50 years or beyond that. So how that is to be leveled and what advantage it has. Some of the things may not be, say, monetable, but then it has also to be factored in. Anyway, this is beside the point. But the thing is that now we know that this gap is to be filled in by nuclear. That nuclear people, when they talked about that cost and time overrun, they thought how to deploy it faster. So there that actually concept of SMR started floating in. If it is factory built, then maybe we are able to reduce this cost and time. So that is how it has come. But then the thing which we have to look at is it a different type altogether? SMR actually nothing but is a nuclear reactor. So being a nuclear reactor, the basic fundamentals are already established. So there is actually no looking back. That fundamentals are going to be the same, which have been same for last 60 years. So those basic fundamentals are not changing. That concept of defense in depth and all that level and including that emergency preparedness, so those are going to be there. So these concepts are known to the technology developers. Now they are adopting new and new methodologies. So what they are going for is some innovative methods in achieving the same this thing. So the regulations which today we have, like Mr. Raghavan also said, like we should look at this risk-based, performance-based or this. So to start with actually going to risk-based maybe a little far in time, but we already have a system which we call it as a performance-based. We are not actually rule-based regulation, where it becomes more or less like a prescriptive. So we already have a performance-based regulation which gives a lot of handle to the technology developers so they can choose their solution. Now they only have to demonstrate that whatever the fundamental requirements are expected, so those are implemented in the manner which is already prescribed and available and which is not going to change. See, some variation, some addition will be there for strengthening measures here and there. So those things exist. So they then don't have to look beyond how their technology has to. Now what remains is that when that review is going to happen, it is talked about that regulator takes lot of time. Now the one thing which we have to look at, why regulator is taking lot of time? Is it that the solution being put forward to the reviewer is complete in all aspects, or it has not been proven? So if more and more R&D is carried out before putting up this to the regulator and it is put up with a complete case, so then this process will get speeded up automatically because the things are already established. So if they are demonstrated that it is satisfying, the things will get speeded up. So this is one of the things which these technology developers have to keep in mind. Let them come with the adequate R&D, adequate safety basis so that reviewer finds it easier to accept that. Or if some changes are required, they are also able to tell it in a very fast manner. Another thing which comes is that we talk about two things. Now this large-scale deployment is going to be there. Whether the present utilities which are there, they will be handled the volume involved. Probably not. So we will need more than one utility or even many more will be required. So then we are going to have a new entities stepping into that. But are going to be that as many entities as going to be the developers? Probably developers are going to be few. And when we talk about people approach regulator, they will approach the regulator with what? They will approach the regulator with some technology. Every person is not going to approach with a new technology. So the technologies which is being put forward to the regulator are going to be few. Yes, when the new technology is put up to the regulator for the first time, it will definitely take a time for review because it happens to be for the first time. But when it is repeated, definitely it doesn't take so much of time. So this aspect also is to be borne in mind, not to get bogged down that it takes so much of a time. So it is the first one, even today also, if any modification is there, first time you put it up, it does take time because it has to be seen threadbare and it has to be reviewed in all details. So if the things are being put forward, definitely it will be cutting down on the time. So the aspect which will remain is that, who will be putting up to? I understand that even the entities are going to be there, but there are going to be some design authorities or the technology suppliers or developers who are going to be behind them. So once they approach, now I expect that they are going to be knowledge with the nuclear field in much more detail than the entities who will be the first timers. And then they know what the regulatory expectations are there. So they are actually understanding between the regulator and those technology developer, not going to be many gap areas are going to be there. So there many hurdles are not going to be there. So this issue of regulation should not arise. See, the present day regulations which we are having are essentially technology neutral. We already have regulation in 3 areas with respect to this water cooled, that is heavy water, as well as the light water and the fast reactors. So basic areas are covered. Now if we talk about that novel, very novel concept, yes, when the novel concepts come, with that the knowledge also will flow to the regulator also. So regulator also will be knowing what to regulate. And as I said, the first one definitely will take a time because everybody has to understand. And another thing is that now the entity is going to be new. When the new entity is going to be there, if the technology, that part is taken, design certification or the design review is carried out properly, then the thing which needs for the regulator to look at specifically is that they have to strengthen their oversight during the operation and the regular phase of this. They are actually, since the entrants are going to be new, some more strengthening or strictness will come from the regulator, because then that trust is yet to build, but with the time that trust also will build and that also will get addressed. So these are the things I think which should not deter anybody how this is going to be there. Is this going to be altogether a different thing that is very difficult to regulate, or for a new entity that it is like I said difficult, they need not enter? I don't think any such apprehension should be there. The new entity can come, only thing is they have to take care that they approach, they have a proper technology developer with them, and then the most important thing which we have to take care is that other technologies, this technology can be unforgiving. So the emphasis which they have to pay is on the quality. So if quality is taken care during all phases, starting from siting to construction and fabrication, if that is addressed, majority of the issues are going to be there. Other things any will be there, will be known to them, and they will all be addressable. One of the point which was raised is actually like what he suggested was with respect to artificial intelligence. I feel that now artificial intelligence, now the clarity on it has to totally emerge, how it is going to be used in the nuclear domain. See, in other areas, other than reactor control and regulation, if it is there, ways and means are available for trying to regulate it. If it is in the domain of control and regulation, so those aspects probably at the moment nobody is talking about, because not only in the field of nuclear, nowhere people are talking about actually directly controlling using AI. Okay, they are using for some decision making here and there, but which is not real time and online. The examples given are that of like that self-driven motor car, etc. But whether that is the right example is still not clear, at least to me. Anyway, those are the aspects which we can look at, and we have to make sure that the expertise and competence is built at all levels, including utilities. If those things are addressed, then there should not be much of an issue. I think with this I will hand it over to
the next panelist, Mr. Vaze.
Good evening. I think my job is a little bit simplified. Almost all the points have already been covered. Chafle has already given a verdict. There is no challenge to regulators. We are capable. And I endorse that, yes. I think it has been proven over a period of time, handling different technologies right from PHWR to LWR, BWR, PWR, so fast reactors, no problem. You throw me anything, I'll handle it. But if we are to pose some challenges, Let us try something here. One aspect of this new technology, SMRs, is that greater use of passive safety systems. Now, perception is that if it is passive, it is reliable. And we tend to give a lot of weightage to that passivity of this. But that is really not so. So there is some work to be done about the reliability of passive safety system. It's there as failure modes of passive system also. It is not that it is not prone to failure. And we have to decide actually how much credit can be given to these passive systems. Then there are some, for example, because of this use of this, our level 4 defense in depth, as Chafle said, that is something which is going to remain irrespective of what technology. Defense in depth is a standard philosophy for regulation of nuclear power. So in level 4, we postulate core melt, and some preventive and mitigation measures are to be employed for that. With this advanced technology, there is a tendency that core melt is ruled out, practically eliminated. So can we reduce this requirement of level 4? That is something, some question needs to be answered that. And if level 4 is eliminated, then do we need actually the level 5, which is the public domain, emergency preparedness? Now logic says if level 4 is not there, level 5 also need not be there. But I read some document, of INSAC document, which has a different point of view. That argument of level 4 does not extend to level 5. Because level 4 up to that is for the nuclear power plant design. Level 5 is for society. So society needs to be, public needs to be protected at all costs. So that decision, we may have to take that. There were mention about early design review. I think Raghavan mentioned that. So actually it is already there in SDG1, that early design review, early site review, preliminary discussion with consultation. But no, so far it has not been implemented. So some way has to be, some procedure has to be read out that this is one good way of shortening the time. That is definitely there. There was a mention about public acceptance, public trust. Now, when we have these SMRs and they are located in a zone where there is a population density of population high, there is at least in my mind, there is a fear that there will be public distrust on this. Even a supporter of nuclear power plant will have a tendency that not in my backyard. So if we try to put nuclear power plants, even of SMRs, in populated zones, the opponents of this will tend to be increased. It will not reduce. Because that fear, it is not a fear. It is that I don't want in my backyard. That's all. That is the only question. Now, I don't know what role AERB has in this. AERB is shown to be reliable source of accurate information. That role, it has been discharging very faithfully, no problem about that. But this, at the stage of proposing a nuclear power plant, whether AERB has any role in that public opinion, if it is there, that role has to be magnified quite a lot. Then we also mentioned artificial intelligence. Actually, when I thought of all these things and that innovative, the first thing I thought is innovative thing will be artificial intelligence. So I prepared something, okay, I will talk about this application of artificial intelligence. Then I searched literature, and there is a document on use of artificial intelligence in nuclear applications. And that is actually co-authored by USNRC, CNSC, that is Canadian Nuclear Safety Commission, as well as ONR, that is Office of Nuclear Regulators, that is UK. So they have envisaged that there is a role for artificial intelligence in nuclear. I share Chafle's opinion that in the case of nuclear reactor the operation control, I am not so sure that artificial intelligence can be entrusted to that extent. But some role can be there. I can imagine some role in accident management. There is a lot of information to be gathered and processed at that time, and in a very fast way. At that time, maybe artificial intelligence will have some role. That document from different regulators, it also says, but it also cautions that there are some pitfalls. Basically, we have to ensure the sanctity of data. Main backbone of artificial intelligence is actually the data. If authenticity data is not ensured, it will give wrong results. So that is the one pitfall there. And what is the level of autonomy that we can entrust with artificial intelligence? That is also one question. But these are the things which we tackle as we go ahead. So we think of some use. Always our process of codes and standards, it goes through some experience. Some experience, then we write something, then some more experience, we write something more, and finally we evaluate it, codify. So similarly in use of artificial intelligence, I expect that as we progress in the usage of this, we will be having some guidelines, codes and guides for that also. I think that completes my view of this topic. Thank you.
Yeah. Thank you, co-panelist. You have almost covered almost everything that needs to be covered in this. So I would just summarize a few things. So what comes out of here is that if the new entities, if the new reactors that are coming up are of any of the technologies that we are using, the sort of boiling water reactor or the pressurized water reactor or heavy water reactor or even the fast reactor, we will have no problem. AERB will be able to handle these things with existing regulations very easily. It now boils down to the small modular reactors, SMRs, of different technology. If it is SMR based on water-cooled reactors, I think that will also not pose any problem. If it is on different technology, then AERB will have some sort of, I wouldn't say difficulty, AERB will have a way of doing it. And that's because the AERB regulations at the high level are technology neutral. They can be applied to that. Then where some sort of prescriptive regulations are there, and one thing is always being talked, prescriptive regulation, I'll give you an example, is the exclusion zone. We need an exclusion zone of a particular radius. And every time people talk about SMRs, they are questioning this particular aspect. I don't see any problem because this also was discussed. At one point of time it was 1 mile, and from 1 mile it was brought to 1 kilometer. At that time, a lot of arguments, AERB was open, and a lot of arguments were made that, okay, we can meet for this reactor at 0.5, the dose criteria. It's a criteria-based thing. It's not, though it was prescriptive, this argument took place based on the criteria. Now we are able to meet, somebody said at 0.5, for this reactor we can meet at 0.5, this reactor we can meet at 0.6, this we. So it is, and AERB was prepared to do all that, but then one aspect came that was kind of security. And AERB also wanted to avoid getting into these things every time for a new reactor comes up. So then when 1 kilometer was proposed and it was covering all the sort of calculations done till that time, AERB decided to adopt that 1 kilometer. But AERB will be open to any other suggestion that will come up. For example, if SMRs want to reduce their thing, and maybe it is possible because of their source term will be small, they will have sort of better containment, so that the dose that may be sort of will be given after an accident may be small. And at the same time, people are also talking about increasing the dose criteria. So if all these things, three things are done, it will be easily possible for ARB to agree to a smaller exclusion zone. But as Mr. Vaze pointed out, will that be acceptable to the public living nearby? So that is a big question that will come. So we may be able to do that, and the onus will be definitely on the proposer, the person who is designing, the person who is proposing. He can prove that I can manage with this particular thing, there will not be any, I am meeting the criteria. If he is meeting the criteria, I don't think ARB will have any objection in taking that. The another point that I want to make out is that a priori this concession cannot be made, because this all depends on doses that will be there after the accident. And when you come to this, level 4, what we call as level 4 of defense in depth, where you address the accident situation and beyond accident situations, these are technology dependent. So unless we know the technology which is going to be used for SMR, it will not be possible for us to make any decision on this. So a priori it cannot be done. The second, the last point that we can make is that the ARB has a process of making regulations. In fact, going through all the history of ARB, we first regulated the PLWRs for some time, and then we came up with regulations for PLWR. Same thing we did for Kudang Bulang, that is the light water reactors. The first two reactors were regulated or given clearance based on the high level criteria, which is performance based, which is goal based. And then when we had sufficient experience on that, we came up with light water reactor code. The fast reactors, we already have regulated the small reactor FBTR, and then now also PFBR, and the code is yet to come. It's under preparation, I understand, but it is not there yet. So we do not have any problem in regulating any kind of reactor that may come up for our review. So with this, I can come to something which is not yet discussed. Morning somebody discussed that. See, this regulatory framework we are talking about, but what we have been talking about is only the safety regulatory framework. There is a framework which is beyond this, and that is under the control of DAE. That is, for if you want to have more entities, if you want to permit a sort of a private entity into regulation, then the regulation will have to start changing at the DAE level, at the Atomic Energy Act level. Now, even if that is done, there are further few questions that come up before us. That is the culture. Somebody had yesterday mentioned, a new private entity comes and we will have, there is a particular, for running the nuclear reactors, for operating the nuclear reactors, a particular safety culture is needed. You got to sort of learn the consequences of this particular, many people try to compare with an aviation industry. And I totally disagree with that, because aviation industry, if one plane crashes, there are some 300 deaths, I agree. But it is for that plane. The people who rescue, they come with the same, plane. But then look at the Chernobyl or look at the Fukushima, the society remains affected for years together, decades together. And a very large number of people get affected. So, these two things cannot be compared. So nuclear reactor, even if it is small, it will still have consequences, if at all, for a long term. They are not going to be short term. So it requires a different culture. So how we are going to imbibe that culture into private entities? That will be the first question. The second question is that the people are not, the fuel and the spent fuel, both the new fuel and the spent fuel. How can you get for the these new entities or private people or whatever? Where from this fuel will come? How that will be controlled? What will happen to that fuel after it has been discharged from the reactor? All these things have to be again institutionalized. Some mechanism has to be sort of made, again not by AERB but at a higher level, to control this thing. Because fuel, and particularly if you import the fuel, there will be safeguards. All these things are to be addressed before anything comes for our discussion. And finally, the radioactive waste. That also is something which, thought has to be given. So finally, even though it is probably said very easily that private entities could come in, I find it a lot of changes may be required, and it will be very difficult to sort of, it will take a very long time, to get these things in place. So with that, now final question comes, okay, now if these are all sort of the restrictions, how can we have that renaissance? Renaissance, what I understand is increasing the nuclear capacity very fast and further. So the answer to that is, for one example very good given is our 700 megawatt, which is now in a sort of a standardized design, and then you order a lot of them, 10 of them. So same thing can be done. You AERB gives clearance, or you get clearance from AERB for a particular type of design, and then multiply it first. You multiply it in numbers. So finally, if you have some 4, 5, 6 designs, and then each of them you build in numbers, it will be possible to go faster, increasing the capacity of our nuclear sort of fleet. So that is the way to go. And thank you very much. I would like to close this.